Hello, ladies and gentlemen. Mr. Dorfley here, checking back in with you. Hopefully, you all had a good Halloween, and my video wasn't too scary the day before Halloween. Okay, too spooky. Anyway, I'm here to discuss and refresh our minds on calculating the formula weights and percent composition of elements in compound. Along with this video, you are receiving some additional practice questions, and I'm going to go over a few of those with you in this video so that hopefully, like I said, refreshes your mind and gets you ready for the super quiz once we come back from our little break here. All right, so I'm just going to hop right into it. What you'll need for this video is calculator, periodic table. That's it. And maybe something to write with. That'll be helpful. All right, so let me get my supplies here. All right, so I'm going to flip upside down. Ooh, I'm talented. All right, and I know I'm going to have to darken this a little bit. Maybe even more. Okay. So I'm trying to get this straight up. All right. So let's take a look at a couple questions here. Let's do a few from part A and a couple from part B. So let's look at number 1, HCl. Okay. So HCl. So in this compound, we have hydrogen and we have chlorine. Okay. Ask yourself, how many of each do we have present here? And we look at the subscripts and we count up if there's more than one element or more than one of the same element in the formula, then we count those as well. So here we've just got 1, and in chlorine we just have 1 as well. So next thing we need to do is look at the periodic table and determine what their atomic masses are. So again, hydrogen is going to have an atomic mass of 1. Again, we're going to use the rounded values here. And so we have 1.0 AMU. And chlorine, if I can keep that paper out of my way, chlorine right here, 35.4527. That first decimal point is still below 5, so we're going to go ahead and round down. And so we're going to round it to 35.0 AMU. So go ahead and multiply through. Again, you shouldn't really need to do that. So 1.0 AMU plus 35.0 AMU. And we get an overall formula weight of 36.0 AMU. Okay? Okay, my keyboard needs to move. So that's number 1. That's starting off, getting our brains moving here. Let's pick another one, shall we? How about number 3, C3H6O2. Okay, C3H6O2. Perfect. All right. So let's list what we have. We've got carbon, we've got hydrogen, we've got oxygen. Okay? We have 3 carbons, 6 hydrogens, and 2 oxygens. Okay, now we refer back to the periodic table and using our rounded numbers, carbon, and if you don't know where carbon is, it's right here, where the tip of my marker is. Carbon's going to be 12 AMU, again, using rounded numbers. Sorry if you get tired of me saying that, but I'm just always reminding you. Hydrogen, again, like we saw, is 1 AMU. And oxygen, pretty close to carbon. It's right here, number 8 on the periodic table. It has a rounded mass of 16.0 AMU. So let's go ahead and multiply what we need to. 3 times 12 is 36 AMU. 6 times 1 is 6.0 AMU. And 2 times 16 is 32.0 AMU. So now we're going to sum up all of those. And if you want to take a moment and sum them up yourself, go ahead. But When you do this, you're going to have 74.0 AMU for your formula weight of C3H6O2. Well, let's backtrack a little bit. C3H6O2 is a molecular compound, so technically this would be a molecular weight. Whatever. But as you saw in the video on Friday, that the book oftentimes will even call molecular weights formula weights. Okay, so we saw that in our practice questions here. So whatever. It won't bother me. Just know that, yes, there's a difference. No big whoop. All right, let's do one more in part A. And let's look at the last one, number 8. Okay. Number 8 is SN parentheses CO3 close parentheses 2. So SnCO3 2. I wanted to throw one in here that had a parentheses as well as a subscript. So we have SN, which is tin. We've got carbon, and we've got oxygen. Okay, there's one tin. Now we got to multiply and send that subscript through to the elements in the parentheses. So there's 2 times 1 carbon, so there's 2 carbons. And oxygen, there's 2 times 3, because there's a subscript of 3 on the oxygen. Okay? Tin's not one that we come across a whole lot, but it's right here. Okay? Right where the end of my marker is. And it's got a rounded, rounded atomic mass of 119.0 AMU. Good carbon, 12.0 AMU, and oxygen, 16.0 AMU. Okay, so let's go ahead and multiply these through. So you have 119.0 AMU for tin. We're going to have 24.0 AMU for carbon, and we're going to have 96.0 AMU for oxygen. Sum them all together. Again, if you need to pause the video, pause it now. But when you sum them all together, you get 239.0 AMU. Again, always check my calculations. I can and have made some errors while calculating because sometimes my calculator doesn't like to enter all the buttons I push. So if you find any mistakes that I make, please tell me so I can correct it. Okay? So there you have 3 examples of how we calculate formula weights of compounds. Let's go to part B. Let's do a couple in part B. Okay, part B, we are to calculate the percent composition of each element in the compound. So let's start off with number 1, SO2. Start off basic here. SO2. The only way that we can determine the percent composition with only the formula is before we can even calculate the percent composition, we have to figure out the formula weight of the compound. So we have to figure out the formula weight of SO2 before we can proceed at all. Okay, so we've got S, we've got O. Okay, there's 1 sulfur, 2 oxygens. Sulfur on the periodic table is number 16 right here. It has a rounded value of 32.0 AMU. Oxygen, you probably know by now, is 16. Multiply through the 32 for sulfur, and we'll have 32 for oxygen for a grand total of 64.0 AMU for the formula weight. Okay. Now, I don't know why my camera is acting goofy. Stop it. What is happening? That's good as it's going to get. All right. So in order to find the percent, we have to take the number of atoms of that particular element, multiplied by its weight, its mass, and divide it by the formula weight and multiply by 100%. All right. So for sulfur, there's 1 atom within each atom has a mass of 32.0 AMU, and the entire formula weight of SO2 is going to be 64.0 AMU. Again, we calculated that the first step. Then we multiply that by 100%, and we're going to find that sulfur makes up about 50% of the overall weight of the formula. But we have to do it for every single one. So oxygen, there are 2 present, each one being 16.0 AMU. Again, divided by the formula weight of 64.0 AMU, that's 64, and multiply by 100%, and you'll also see that 50%. So the oxygen, having 2 present, they make up 50% of the overall mass of the molecule. Sulfur, it takes up about 50% as well. Pretty straightforward on that one. All right, now let's look at all right, let's look at number 4, CH2O. CH2O. All right. Again, we are tasked with the same question. We have to determine the percent of each element in the compound. But first, we have to determine the formula weight. Carbon, hydrogen, oxygen. You're going to see these combinations of letters very often. All right. Carbon, there's 1. Hydrogen, there's 2. Oxygen, there's 1. Carbon is 12.0 AMU. Again, hydrogen is 1. And oxygen is 16 AMU. Multiply through. We got 12 AMU plus 2.0 AMU plus 16.0 AMU. And we get a formula weight of 30.0 AMU. Okay, we've determined that now. So now let's go ahead and determine the percent composition of each element. So carbon, okay, carbon, there's 1 present, multiplied by 12.0, divided by 30.0. Again, these are AMU. I'm just kind of doing a shortcut right now. And so when you put it in your calculator, 1 times 12 divided by 30, multiplied by 100%, and you find that carbon gives us 40% of the overall mass. Okay? Now we have to do it for hydrogen and oxygen. Hydrogen is equal to, there are 2 present, each one is 1.0 AMU, divided by 30.0 AMU times 100%. So again, anytime you want to pause the video so that you can check your calculations yourself. And I don't know why that is like that. That's a little better. All right. So 2 times 1 divided by 30 times 100, you should get approximately 6.7%. Now, you'll probably have kind of a run-on number there. Just round it, okay? Make it 1 decimal point and round it. And then lastly, we've got oxygen. Again, there's 1 present. 16 AMU is the mass of a single oxygen atom, divided by the formula weight of 30 and multiplied by 100. We should get 53.3%. And so, if you were to add all of these up, okay, 40 plus 6.7 plus 53.3, you should have a grand total of 100%, which, you know, is always a good way to check. But in the video on Friday, when we did this first practice, I said that there might be situations to where you are maybe a few decimal points shy or over the 100%, and that is fine. That is kind of the nature of the beast when you round stuff. But typically, if you round it, we should have pretty spot on the 100%. But again, a few decimal points here and there are going to be just fine. Okay. Well, anyway, that's just going to wrap up the video. Very brief video, like I said. I just wanted to touch base with you, refresh with you the stuff we learned in the previous video, getting you ready for the super quiz coming up the day you return on November 4th. So again, if you have any questions on this, get a hold of me. You know where I'll be. But yeah, make sure you get this completed and resubmitted back into this assignment. And make sure to check the due dates. Until then, I will see everybody later. Bye-bye now.